On August 12th, daylight will collapse along a narrow path stretching from the Arctic to Spain. In northern Spain, the black sun will hang only degrees above the western horizon. Most observers inside the path will receive less than 2 minutes of total darkness. At the global maximum, totality will last only 2 minutes and 8 seconds. Clouds, mountains, or one blocked horizon could hide a spectacle unseen from mainland Spain since 1905.
Above the weather, a NASA jet will chase the moon's shadow at 460 miles per hour.
Scientific balloons will rise, and hours later the moonless Perseid meteor shower will approach its peak. Every total solar eclipse begins with a remarkable alignment of the Sun, Moon, and Earth. The Sun is vastly larger than the Moon, but it is also vastly farther away.
From Earth, their apparent sizes can nearly match, allowing the Moon to cover the solar surface.
The Moon casts two principal shadows, a broad penumbra and a much smaller, darker umbra.
Inside the penumbra, observers see a partial eclipse because some of the sun remains exposed. And
only inside the racing umbra does the Moon completely block the Sun and create totality. That umbra traces a narrow corridor across Earth, called the path of totality. Move only a short distance beyond its edge, and the eclipse remains partial, never total. During the partial phase, the Moon appears to take an ever larger bite from the Sun. Just before totality, sunlight streams through lunar valleys, producing brief points called Bailey's beads. The final brilliant point creates the diamond ring effect as the surrounding corona begins to emerge. Then the Sun's bright surface vanishes, revealing its faint, sculpted outer atmosphere. The 2026 shadow begins its journey in remote northern Russia and moves into the Arctic. It sweeps across the high latitudes, where the Sun stands higher and totality arrives earlier. The umbra then crosses northeastern Greenland, racing above ice, mountains, and isolated settlements. Near the central path around Greenland and the North Atlantic, darkness lasts slightly longer than 2 minutes.
Western Iceland is next, experiencing totality during the late afternoon or early evening.
Here, volcanic landscapes and Atlantic weather could produce either unforgettable views or complete disappointment. No long-range forecast can guarantee success. Eclipse chasers must follow reliable updates close to the event. The shadow leaves Iceland and crosses the North Atlantic toward the Iberian Peninsula. A small corner of northeastern Portugal enters totality before the shadow completes its European passage. In Spain, the path first reaches Galicia and then cuts across the country from west to east.
At A Coruña, the eclipse begins around 7:31 p.m. and reaches maximum near 8:28.
Totality there lasts about 76 seconds, with the Sun 12 degrees above the horizon.
The shadow continues across northern Spain through regions including Asturias, León, Cantabria, and the Basque Country.
At Burgos, totality lasts roughly 104 seconds, with the Sun only 8 degrees high. The path then advances across inland Spain toward Zaragoza, Teruel, and the Mediterranean coast.
Cities including Valencia lie within the broad northern Spanish corridor of totality.
By Palma, maximum eclipse arrives near 8:32 p.m., with the Sun just 2 degrees high.
Along the eastern end of the route, Sunset interrupts the final partial phase.
This will be mainland Spain's first total solar eclipse since 1905.
It begins an Iberian trilogy, another total eclipse in 2027, then an annular eclipse in 2028.
Spain's low evening sun makes the event beautiful, but it also creates a serious viewing challenge.
A hill, building, tree line, or distant mountain can completely block a sun near the horizon. Observers need a clear western view, verified in advance from their exact coordinates.
The center line is not automatically best if access, terrain, traffic, or weather makes it unusable.
Choose a safe site early, then check official maps, local restrictions, and the late weather forecast.
The experience begins quietly, as first contact removes a tiny curve from the solar edge. Over the next hour, the crescent narrows while daylight becomes strangely pale and metallic. Small openings between leaves project hundreds of crescent suns across the ground. Air temperature can fall, winds can change, and the atmosphere begins behaving like evening. Birds may settle, insects may change rhythm, and people instinctively lower their voices. Near sunset, the entire horizon may glow while the moon's shadow approaches from the west. In the final minute, shadows sharpen, and the remaining sunlight becomes almost colorless. Bailey's beads flash, the diamond ring collapses, and the landscape drops suddenly into twilight. Only now, inside Totality, may observers briefly view the fully covered sun without filters. A black lunar disk hangs inside the pearly corona, unlike any ordinary night sky. Pink-red prominences may appear along the edge, tracing solar plasma above the hidden surface. Bright planets and stars may become visible if the sky is clear and transparent. But 76 or 100 seconds pass brutally fast when every detail demands attention. A second diamond ring announces the returning sun and the immediate end of safe, unfiltered viewing. Eye protection must return before even the smallest bright portion of the sun reappears. For scientists, Totality creates a natural coronagraph. The moon blocks the dazzling solar surface. This exposes the corona, a plasma atmosphere heated to nearly 1,000,000 degrees.
Researchers study its structure, prominences, outflows, and relationship to the solar wind.
NASA will carry 4 specialized cameras aboard a WB-57 high-altitude research aircraft. Flying at 460 miles per hour, the jet will extend its view to nearly 3 minutes. The aircraft will operate around 50,000 feet, above clouds that could defeat observers below.
Its cameras will record at least 20 images each second in visible and infrared wavelengths. That altitude reveals infrared light normally absorbed before it reaches instruments on the ground.
Scientists hope to trace rapid coronal changes and understand how its material feeds the solar wind.
NASA-supported student teams will also launch scientific balloons from Iceland and Spain. In Iceland, 80 balloons will launch from 18 hours before the eclipse until 8 hours afterward. They will test how sudden darkness changes Earth's boundary layer, the atmosphere touching the ground. Earlier eclipses showed that this layer collapsed under clear skies, but behaved differently beneath clouds. In Spain, 6 balloons will carry panoramic cameras and instruments that measure atmospheric ozone.
Researchers will test whether ozone falls again, as similar experiments observed during the 2024 eclipse. From high above, cameras may capture the moon's dark shadow moving across Earth's curved surface.
ESA will broadcast from Havilambre Observatory in Teruel, directly inside Spain's path of totality.
The event also connects with European missions continuously studying the Sun and its influence on Earth.
Ordinary sunglasses are never safe for viewing any bright portion of the Sun.
Use genuine eclipse viewers compliant with the ISO 12312 WELF-2 International Safety Standard.
Inspect every viewer for damage, supervise children, and put protection on before facing the sun.
Never look through binoculars, telescopes, or cameras while merely wearing eclipse glasses.
Optical equipment requires a purpose-built solar filter securely attached to its front.
Outside totality's exact path, the sun remains partially exposed, so filters must never be removed.
Without certified viewers, use an indirect pinhole projector with the sun safely behind you.
After the eclipse, darkness returns naturally beneath a nearly moonless sky. Overnight, Earth encounters the Perseid stream, debris left behind by Comet Swift-Tuttle. Those grains strike our atmosphere near 59 kilometers per second, producing bright, swift meteors. Eclipse at sunset, Perseids after midnight, August 12th offers an extraordinary double encounter with the sky. For a few minutes, Europe goes dark. Afterward, the sky keeps telling its story.